simplify each expression. And here we're given 4 expressions that have 0 as an exponent, which is something we haven't really seen until now. The rule that we use is whenever we have a quantity raised to the 0 power, that 0 exponent turns the base into a 1. So if we had 7 to the 0 power, it would be 1. If we had 1,000,000 to the 0 power, it would be 1. If we had 0.368 to the 0 power, the result would be 1. The only exception, 0 to the 0 is undefined. It's kind of like dividing by 0. It's something we can't do. But any other quantity to the 0 power is 1. So let's look at these problems. Let's look at 4 to the 0 power. Well, if we take 4 and raise it to the 0 power, that just becomes 1. All right. The next example is x to the 0 power, which we've just seen is equal to 1. We will just assume here that x is not 0, because 0 to the 0 is undefined. So there we've got x to the 0 is 1. Now this one's interesting. If we have 3x to the 0 power, we have to talk about what gets affected by the exponent. Now here, the exponent of 0, the base is x. 3 is just something that's getting multiplied by it. So we have to deal with the exponent before anything gets multiplied by 3. And if we look at x to the 0, we know that that's 1. So in this case, we've got 3 times x to the 0 is the same as 1. So 3 to the 1 is going to be 3. Having an exponent of 0 doesn't guarantee that the final answer will be 1, just that the exponential expression containing that exponent becomes 1. Now we've got one more here, 3x all raised to the 0 power. Now in this case, the base of this exponent is the whole set of parentheses. So everything in there turns into a 1, and so the final answer here is 1. Another way to look at it, though, we know that if we have a product raised to an exponent, we can distribute that exponent to the factors. So we could write this as 3 to the 0 times x to the 0. However, 3 to the 0 is 1, and x to the 0 is 1, and 1 times 1 is 1. So we get the same answer if we look at it that way. In fact, there are a lot of situations where we'll have an expression, and there are multiple ways that we could go about using the rules of exponents to evaluating it. And usually when we do this, unless you make a mistake, you should get the same answer regardless of what order you apply the rules or properties in.